let's try to understand how do we expand a determinant and how do we get the value of a determinant. Okay. Now in a very simple sense, to understand what exactly is a determinant, now you need to understand the basics of physics. See, whenever you have any vector, okay, any vector, if you can understand, suppose say we are going to have, see, you have y-axis and x-axis. Say, assume that we have two vectors. Fair enough. Say one vector is, let's say vector A is equal to just 5i plus 0j, which basically is going to be this vector, which is along the x-axis. Say you have another vector B, which is 3i plus 4j. Now that means it's going to be something like this. Now what we'll do, we'll try to find the area which is bound by these two vectors. In the sense, I'm going to write it like this and I'm going to write it like this. See the area which is in between. So this area is the area bound between the two vectors, correct? Now for this one, if I represent this I and j in terms of a matrix, okay, in terms of matrix, in the sense, so I can call this as some matrix R is equal to 5i and 5i 0j, correct? So 5i 0j, and for the next one this is going to be 3i 4j, correct? 3i 4j. In the sense, my column represents I and j, and the row represents first vector, second vector, correct? This is what we are looking at. Now I'll try to find the value of basically I'll try to figure out what is the area of this particular parallelogram. Now that area of the parallelogram is technically the determinant of this particular matrix. Okay, determinant of the matrix. Now how exactly are we going to calculate this determinant value? So to figure out the determinant, what we do, we write mod of R. I mean, the symbol what we use is the same thing as modulus, but when you pronounce it, you have to tell it as determinant of R. So determinant of R will be determinant of 5, 0, 3, 4. Fair enough? Now since you have 5, 0, 3, 4, now what we do, whenever you take this value 5, okay, this value 5, now you do not consider the row, you do not consider the column. Okay, again I'll repeat, whenever you consider this number 5, you do not consider this row, you do not consider this column. So what is the remaining element? 4. Correct? So now what do? We take it as 5 times 4. 5 times 4. Okay. Then for the second part, what do? You take the second one, 0. For 0, again, do not consider this row, do not consider this column. Which is the remaining element? 3. Correct? So now what do? So we are going to take minus, here we take these two. 3 into 0. 5 into 4 minus 3 into 0. So what are we going to get here? So this is going to become 20 minus 0, which is 20. So determinant of R becomes 20. Now let's look at the figure. So in the figure, let's try to calculate, graphically. So graphically, if I try to calculate this one, see what's going to happen from here. If you draw a perpendicular, see this one. See, what do you know is that this distance is 5 because it's 5i, and this is 3 and this is 4. So the vertical distance is 4. That means the height of a parallelogram is 4 and the base is 5. What is 5 into 4? 20. Isn't it the same as the determinant value? In the sense, whenever we talk about determinant, the determinant gives the value of the area which is under the two vectors. But here, matrices and vectors, they go hand in hand. So whenever we talk about a matrix, we represent them in terms of matrices. And matrices can be represented in terms of vectors. Alright. So now I'm going to show you the general way of representing the determinant of a 2 cross 2 matrix. Then we'll go for 3 cross 3. Fair enough? For a 2 cross 2 matrix, suppose say determinant of A, say determinant of, say this is A11. See, A11 represents first row, first column. Next A12, A21, A22. Okay. Now, see, what you need to do is first multiply these two, and then after that multiply these two, and in between you should have a negative sign. Okay. So what you are going to have is A11 into A22 minus A21 into A12. This gives you the determinant of this particular matrix A. Determinant of matrix A. Okay. Now in the next one, I'll show you the same thing for a 3 cross 3 matrix. For a 3 cross 3 matrix, suppose let's say we'll start with general one. Okay. Then we'll go for the specific one. Suppose say you have matrix A. So determinant of A we need to calculate. So this is equal to determinant of A11, A12, A13, A21, A22, A23, A31, 32, same thing 33. So we have total of 9 elements. Now in the first case, what do you have to do is, you have to take the first element. Do not consider the first row and do not consider the first column. Remove these two. Fair enough? So if you remove these two, so you are going to have A11 into determinant. So you can write determinant of A22, A23, then A32, then A33. See, that means when you remove this row, when you remove this column, you have 4 elements. Those 4 elements are nothing but 2 cross 2 matrix, isn't it? So determinant of this. Then after that, what you are going to have? So we need to start with minus sign. Minus. Okay. Then the second part, that is going to become, see, we are looking at the second one. So again, remove this particular row and remove this column. Remember, the particular row and particular column should be removed. Fair enough? So in this case, what we are doing, we are going to remove this row, remove the column. See the elements? A21, A23, A31, A33. Correct? So in this case, you are going to have minus A12 into determinant of A21, A23, A31, A33. Then we are going to have a plus, alternate plus minus. Next we are looking at A13, correct? So A13, this is the row, this is the column. Again 4 elements, correct? So in this case, plus A13, determinant of A21, A22, A31, A32. So we are going to have 3 values now. See, if you expand this one, A22, A33, that's nothing but the same as expansion of a 2 cross 2 matrix, correct? So we are going to have the final answer, A11 into A22, A33 minus A32 into A23 minus A12 into A21 A33 minus A31, A23 plus A13 into A21, A32 minus A31, A22. This is a complete expansion. Okay, now in the next video, you have certain examples and problems what we will solve. Then you guys will have a clear understanding as to how to expand a 3x3 determinant, how do we evaluate a 2x2 and a 3x3 determinant. Okay, so in the next video, we'll look into more of examples and then how do we get the value of a determinant.